So let us now talk about the unpaired t-test. It is about two different data that are unrelated with each other. They are independent of each other. This is a comparison between, say, two students, two different schools or two different sections, whether the results obtained between two different sections are really significant, the difference of result is really significant or not, or the difference of weight, biomass, or length of something is significantly different or not. So any quantitative data like this can be subjected to student t-test to find out the difference, whether the difference of the particular quantitative value is significant or not. So here the null hypothesis is this, that the h0, that the two values of this x1 and that of this x2, these are the two data, are not significant, and the HA, the alternative hypothesis is they are significant. These values are significant. The difference of the mean of these values, these quantitative observations that were made, are really significant. This is the alternative hypothesis. So now let us prove this, which of the hypothesis is correct, is acceptable, or which one is rejectable. So we know that for an unpaired t-test, the t-value is equal to difference of mean of these two data divided by the standard error of difference of means. In case of unpaired t-test, this SAD, standard error of difference of mean, is calculated as the standard deviation square root of 1 by n1 plus 1 by n2. So this is the formula for calculating this. So after finding out this value, if you divide the mean by this value, the difference of means of this value, you get the t value, and then you compare the t value with the t distribution table at a particular degree of freedom. There are 10 observations of each, so the degree of freedom is 10 plus 10 minus 2, so it is 18. Now let me show you how these data were obtained. Let me wipe these things out and go to the Excel. So let me first delete these things also and start from the beginning. So I'm deleting this value also, this one also, these two values. Let me delete these also. Sorry. Okay. So now we have these two groups of data. This one, say these are the body masses of fishes obtained from two different ponds. We can say this one and this one. So what is whether the difference of body mass is significant enough or is insignificant? Let us test that by this unpaired t-test. So first of all, we need to calculate the mean value of that, and that is equal to average of this one, and similarly this is the average of these values. So you got the averages, that is the mean. The degree of freedom is 18, already calculated. So now let us find the deviation, that is D1. Deviation is deviation from the mean. So it can be calculated like this, minus $B $. What is the shell number? Sorry, it is 34. It is 34. So 34. So it gives the deviation from the mean, that is 2. No, it is incorrect. It should be 4 because the mean is 24 and this is 20, so it should be minus 4. Some error has occurred. Minus, this will be minus 23, that's okay. Be 34. no, this is 33. Oh, this is 33. So shell number is 33, in which the mean is there. Because we are calculating the difference from the mean, there is a deviation. Now let us square the deviation. So squaring the deviation means select a particular class, then square sign. So you get the square of that. This is done to cancel the negative signs only. So here also we'll do the same thing. We first find the deviation and then $E $33. So this gives the deviation of second group of data, and this is the square root of that, not the square root, square of this, and then drag to find the others, square of the other data also. So these are the data that you obtain by combining. Now let us sum up this data. So sum of this, all these division squares gives you a value 136. Similarly, it will give you value 192 of the second data. Now the combined standard deviation is calculated by a formula. That formula, let me go to this one. The combined standard deviation, or the pooled standard deviation, is equal to square root of the summation of d1 square plus d2 square, okay, divided by n minus 1. Here the n, there are two n, so n1 plus n2 minus 2 will be the degree of freedom. So this is how combined standard deviation is calculated. So now let us find out the combined standard deviation. Combined standard deviation can be calculated. Let us calculate all these values separately. First, the numerator, that is the summation of the first square of the deviation of the first group with that of the second group. That means it's equal to this plus this. So it gives a value 328. Now dividing it by the degree of freedom gives you the value 18.22. And now let us find out the square root of it. So it gives a value of 4.268. Now let us find out the 1 by n1 plus 1 by n2 value, because in the formula you can recall that the formula contained formula for t-value calculation. The formula for t-value was x1 mean the difference of the means by standard error of differences of means. For calculating this, the value was sigma into sigma square root of 1 by n1 plus 1 by n2. So we need to find out this. Then multiplying this with the sigma, with this one, will give us this value. So let us first find out this one, 1 by n1 plus 1 by n2. What is that? Equal to 1 by n1 is 10 plus 1 by n2 is also 10, 1 by 10. So it is 0.2. A square root of that is SQRT, square root of this value. So it is 0.447216. So therefore this standard error of difference of the means is, that means this value is, the numerator is given as multiplication of this, product of this with that of this one. So it is 1.909 is the standard error of mean of difference between the two data. So the t value is therefore t value is therefore difference of means of the two data divided by this SAD value. So it is 7.33. So in a t distribution table, you can see that at degree of freedom 18, and the degree of freedom is 18, at 0.05, what is the, sorry, this column, the value contained 2.878. The table value is 2.878. So the table value for at a probability 878 is the table value. So which is lesser than this value. So this is the null hypothesis stands rejected here. That means the difference between these two data, x1 and x2, are significant enough. The alternative hypothesis is accepted. The null hypothesis said that these are insignificant, but the t value obtained is higher than the table value. Therefore, the alternative